8.9 Simple Event Probability. Learning Objective. I can calculate the probability of simple events. Again, probabilities are numbers between 0 and 1 that describe the likelihood of events. So remember, anything between 0 and 1, this could be a decimal, this could be a fraction, this could be a percentage. Every once in a while, people will write probabilities with odds as a ratio, so like 1 to 2. I won't do that. It does happen, but it's not very good form to talk about it that way. It kind of means something different. So I just want to get you guys familiarized with the fact that probabilities could be decimals, fractions, or percentages. Okay. We calculate probabilities by taking the number of desired outcomes, the thing we're looking for, divided by the total number of possible outcomes of all the possibilities. So let's talk about an example because I think that helps a lot with probability. If we wanted to know about the GPAs of students in our class, we could look at the following histogram. Now remember, we have already learned about histograms. So what this is telling us is that we have some number of students with GPAs. So simple probability would ask, if you randomly selected one of these 21 students, what is the probability that their GPA is between 3.0 and 4.0? So this range of GPA falls in interval 4. So these are GPAs. So between 0.0 and 1.0, between 1.1 and 2.0, between 2.1 and 3.0, and from 3.1 to 4.0. Okay, so this would be interval 1, interval 2, interval 3, and interval 4. And we're saying if you put all of these students' names in a hat and drew out one, what is the likelihood that it would be one of these 4 students? Okay, that's what we're asking. So it would be 4 of our students that would give us our desired outcome. Okay, we're wanting this. That's our desired outcome. So that would be 4 of them divided by the total number of possibilities. Well, if there's 21 students' names in the hat or bag, then we can do 4 out of 21. Now you can leave this as a fraction. That is fine. In fact, that's what I would most prefer. Okay. So then there's a couple other things that we could look at with simple probability. We could say, well, what's the probability that they fall in interval 1? So that's these students right here. So then that's our desired outcome. It would be that one student that's here would be our desired outcome. And there's still 21 names that it could be. You could leave it just like that, 1 out of 21. This one says, what's the probability that the student you pull out has a GPA above 2.0? Okay. So which students even have a GPA above 2.0? Well, that would be all of these and also all of these. So our desired outcome would actually be these combined. So the 11 plus the 5 would be the 16, and there's still 21 names in the hat. Okay. Now this one asks about the probability of it being in interval 2. What's the probability that the student falls in interval 2 with the GPA? So that's these students. This one is 4 out of 21. Okay. And for the probability that they fall in interval 3, this is interval 3. How many students are in there? 5. Okay. Now, for our last one, what's the probability that it falls below 3.0? So here's your 3.0 mark. So what are the odds that your student is from this section of the histogram? So we would do 5 plus 4 plus 1. So that's going to be 10 out of the 21 possibilities. Okay. Now you should reduce these fractions if you can. None of these are reducible, so that's why I didn't. Okay. So there you go. Those are the probabilities that any of these things could happen. Let's do another example. There are 6 people in our class that say their favorite color is purple. Okay, so I'm just going to go ahead and highlight that, and let's put it in purple so it's not confusing. Okay, so we've got 6 people who say their favorite color is purple. Okay, there are 4 each that say their favorite color is green and blue. Okay, 4 each. So that means there are 4 with green, but it also means there are 4 blue. Okay. There are 7 who say their favorite color is orange. And there are 3 each that say their favorite color is red and yellow. So again, 3 each means there are 3 yellow. But there are also 3 red. Okay. So remember, we need to do our desired number of outcomes divided by our possible outcomes. So in order to get that possible outcomes, we need to total up how many people we even asked. So we had 6 say purple, 4 say green, 4 say blue. 7 say orange, 3 say red, and 3 say yellow. So we would have to add all of these together to get our total of our desired outcomes. So I'm going to open calculator again. Oops, wrong button. Sorry, we don't need YouTube. Nope. My goodness, we are having technical difficulties. Here we go, finally got it. Okay, so to know our total number of outcomes, we would have to do 6 plus 4 plus 4 plus 7 plus 3 plus 3. So that means we had 27 people in our class that we asked this question. Okay, so there are 27 possible outcomes. So let's just start with what is the probability that their favorite color is green. So that's how we read this. Okay, what is the probability that the outcome is green? So we put all these students' names in a hat, and we pull one out, and we say, how likely is it that the person's name that we pull out's favorite color is green? So we take the number of green, which is 4, and we divide it by the total number of people in the hat. So that's going to be 27. So 4 out of 27. Okay, so what about for blue? Well, blue's the same because there were also 4 people who said their favorite color was blue. For purple, again, it's always going to be out of your total outcome possibles. So 27 on the bottom. And for purple, there were 6 people who said that, so we'd put 6 on the top. Here's a good example of a fraction that can be reduced. This should actually be 2 over 9. Okay? One way you could read that is there's a 2 in 9 chance. Okay? And that's why you should reduce whenever possible. It just makes more sense to people. Okay, so for orange, we had 7 that said their favorite color was orange and 27 total people that we asked. So I want you to try and do yellow and red on your own. I will tell you yellow and red can both be reduced, so make sure to do that. Okay, we're going to skip over here to this one though. What is the probability that their favorite color is not green? Well, if their favorite color is not green, it could be any of them but the people who say their favorite color is green. So you're still going to have 27 total possibilities of people that we're asking. But if it just has to not be green, there's only 4 people that said their favorite color was green. So that means that 23 people would say their favorite color is something other than green. So for this one, we would actually say 23 over 27. You can think about this like adding all of them except for the green one. So you could do 6 plus 4 is 10, plus 7, or here we'll do 7 plus 3 is another 10, so 23 that are not this green one. You can do it that way too, but I think it makes more sense just to minus the ones that are not in green. Okay, then we're actually going to skip to the last one. What's the probability that they said their favorite color was white? Well, that's impossible because none of them said their favorite color was white. So the probability is 0. Okay? There is no way that you can pull a name out of the hat that said their favorite color was white because nobody said their favorite color was white. So going back to what we learned yesterday, that's impossible. It has a 0% chance of happening because nobody in our class said their favorite color was white. Okay. Now, green or yellow, this one's a little bit tricky. So I kind of just wanted to point this out, just kind of as a, hey, isn't this cool? You don't necessarily need to know this for your test, I don't believe, but it is cool. So what's the probability that it's green or yellow? Well, we still have 27 people that got asked. 4 said their favorite color was green. 3 said their favorite color was yellow. So what's the likelihood that either their favorite color is green or yellow? We would actually add these, okay? Because any of these 4 people could get drawn out and this would be true. Any of these 3 people could get drawn out and this would be true. So we actually add them together. So this one's probability is actually 7 over 27. And I'm going to move some things so it's more clear that that goes together. Okay. So that one's just kind of a fun, hey, what do you do when this happens with this or in there? And turns out you actually add them together. So that's kind of fun. Okay. That should do it for our simple event probability. Make sure you get your 8.9 homework done.